Okay, these notes are for Integrated 2, Section 6.1.4. We can do a little bit of review, hopefully, from previous math classes. If not, we are going to go through this thoroughly too as well. So if you take a look at this, we're going to be talking about radicals. Well, radicals is just another name for roots. So whenever you hear a radical, we're actually talking about a root. Now, it doesn't have to be a square root. So I'm just going to put an n in there. So it could be the square root. It could be the third root. You might have a little 3 in there. Fourth root, a little 4 in that crease. And then how they relate to fraction exponents. All right. So they do have a very close relationship, actually. Okay, fractional exponents. So here's some of our patterns. Can be written a couple of different ways, and we are going to go through and practice these. But the idea here, so this is what I prefer to think of it as, is if you have a fractional exponent, so if we have x to the m over n, so m over n is our exponent. I prefer to think of it as two different things. So I'm going to let the top represent the power, and I'm going to let the bottom represent the root. So I always think of it as x to the power over root. So if I rewrite this, I'm going to create a root, put the x inside, so the base of this. So if we have another clarification here, this x number or value is called the base. So the base gets put inside. Then we're going to take the power, and the power remains as an exponent on the base. The n becomes the root. It's the number that goes in the crease. So this is the way I think about it. It's power over root. And you can see that with the other examples there too. But I think I'm going to go ahead and go to the first problem that we have to work out. So I would see that the 1 on top, that represents the power. And the 4 on the bottom represents the root. So if I rewrite this, I'd open a root, put the 16, the base where it belongs, put the power on the base, and put the 4 in the crease. Okay, so this doesn't seem all that exciting so far. However, we can clean this up. Anything to the first power, so what's inside, doesn't change. So we're going to rewrite this as 16. Now, the thing in the crease. Just like when we did square roots, we looked for pairs of the same number that belong together because a square root implies a second root. So you want two things to match. If we are looking for a fourth root, then we want 4 of the same thing to match. I'm going to approach this the same way I did with those. I'm going to make a tree. So let's take this 16 on the inside and let's break it down into its prime factorization. So I know 16 can be rewritten as 4 times 4, neither of which are prime. I'm going to keep going. The 4s can be written as 2 and 2, both of which are primes. Let's go ahead and circle those. 2 and 2, let's circle those. Okay, we can't go any further. So what I'm going to do is I'm going to replace the 16 on the inside with a 2, and I have 4 of them, so the 4th power. Now, something pretty nice happens. When we had a square root and a squared, they canceled. We get the same thing here. If you have a 4th root and a 4th power, then the powers and the roots also cancel, as long as those numbers match. So this root and that 4 disappear, and that 4 disappear. Looks like the answer is just 2. So it's a lot of what we did previously with the simplifying part. Just the beginning part's a little strange. Okay, so let's take a look at question number 2. Same idea. Number on top represents the power. Number on the bottom represents the root. Now, typically, the power is going to blow something up and make it bigger. The root is going to shrink it down and make it smaller. So I'll think about what I want to do here. So I'm going to rewrite this as the 9, and then bring my power, 3, put my root, 2. Okay, I'm going to rewrite this. I prefer, personally, if I can, to shrink something down first and then blow it up if I have to. So I like to do the root first. So I'm going to rewrite this so that it looks like I'm doing the root first. Now you can move the roots, the exponent, so that it's either inside the root or outside the root. So it doesn't matter which one gets done first. So I'm going to rewrite this so that the cubed gets done after the fact, which is totally fine. I'm totally allowed to do that. Now I'm going to look inside. And I'm going to ask myself, do I know the square root of 9? Yes, I do. It's 3. So I know I can simplify that thing inside the parentheses as 3. Now, carry down the exponent with you. Now blow it up. Notice that we don't have the root anymore. So if I want to do 3 cubed, well, 3 cubed, remember an exponent tells you how many things you're multiplying together. And I know that 3 times 3 is 9. 9 times 3 is 27. That's my answer. Now, you could have blown it up first and done 9 cubed, but that's huge. Then you would have had to square root it. I think that it's easier to shrink and then blow up. It doesn't always work that way, though. But in this case, it did. Okay, let's take a look at the next one. So exponent on top represents the power. The bottom represents the root. So let's see if we can rewrite this. So open a root, put the base inside, put the power inside. I can move it outside if I want to in a second. Put the root in the crease. Okay, I do not want to do 4 to the 5th because that's going to turn this thing huge. So I'm going to see if I can redo it so that I'm putting the exponent on the outside. So just like what I did on the previous problem. So leave the 4, keep the 2 in the crease, and let's put the power on the outside. So I'm going to do the inside first, so the root part. Okay, I know the square root of 4. It's 2. So this is 2. Bring down the power. All right, 2 to the 5th. Notice there's no fraction exponent anymore. It's just an exponent. So I have 2 times 2 times 2 times 2. Remember the exponent here. So the exponent of 5 tells me how many of those 2's I'm actually multiplying together. All right, so if I do 2 times 2 times 2 times 2 times 2, I believe I get 32 as my answer. So that's just a little bit of practice with roots and exponents. So roots can be transferred into exponents, fractional exponents. So we can even do something as basic as, and you can type it into your calculator like this too. I know that if I had 4 square rooted, so just hypothetically separate answer, if there are no power or root, well, the power that you don't have to write down is a 1, because anything to the first power is just whatever that anything is. If you have this root symbol, it is understood that there's technically a 2 in the crease. Technically. Now I can rewrite this. So I keep the base, and remember it is power over root. So the square root of 4 is the same thing as 4 to the half power. Okay, the only other thing I want to talk about in this video is on the next slide, and it's in your notes, and it's really just the number system. So this is kind of reaffirming the stuff that we've already talked about earlier in the year. You did get introduced to imaginary numbers earlier. Now, complex numbers represent every single number that you are aware of, whether they are real or imaginary. Doesn't matter. Every single thing is identified as a complex number. Now, if we shoot off to the right here for real numbers, everything under real numbers, these are numbers that you guys have been working with for years. These are fractions. These are positive. These are negative. These are 0. These are decimals. These are all sorts of the different numbers. The other category that we have, which are not real numbers, are imaginary numbers. And that was the square root of -1 that we introduced earlier this year. So that's all this last one is. It's just kind of an organization of how the number system actually fits together.